Last time we have seen that if in the non-homogeneous linear differential equation with constant coefficient, q of x is of the type x into v, where v is a function of x, then how to obtain its particular solution? We have seen the theorem 1 upon f of d operate on x into v, where v is a function of x. This is equal to x 1 upon f of d operate on v minus f dash d upon f of d whole square operate on v. We have seen the theorem, this theorem and its proof. Now, in today's lecture, we want to see the example based on this topic, means examples of the type in which the non-homogeneous differential equation is of the type x into v. We see the first example, solve the equation d square plus 5d plus 4 of y is equal to x sine 2x. Now to find the general solution of this non-homogeneous differential equation, as our usual method, first we find the complementary function. For that purpose, we first consider the associated homogeneous differential equation is in the bracket d square plus 5d plus 4 bracket complete of y equal to 0. And from this we write the auxiliary equation is m square plus 5m plus 4 is equal to 0. This is a quadratic equation in m. We want to factorize this. The factors of this are to be m plus 1 into m plus 4 is equal to 0. Therefore, values of m are minus 1 minus 4. Therefore, the auxiliary equation have real and non-repeated roots. Therefore, the complementary function yc is equal to c1 e to the power minus x plus c2 e to the power minus 4x. This is the complementary function. Now we want to find the particular integral yp is equal to 1 upon f of d operate on q of x, and this is equal to 1 upon d square plus 5d plus 4 operate on x sine 2x. Now if we see here q of x is x sine 2x, this is of the type x into v, where v is sine 2x, and here f of d is d square plus 5d plus 4. Now we use our result for this 1 upon f of d operate on x into v is equal to x 1 upon f of d operate on v minus f dash d upon f of d whole square operate on v. We use this result for this example, and here f of d is d square plus 5d plus 4 and v is sine 2x. Then we obtain this yp is equal to x 1 upon f of d is d square plus 5d plus 4 operate on sine 2x minus f dash d is 2d plus 5 upon f of d whole square operate on v, where v is sine 2x and f of d is d square plus 5d plus 4. Therefore, its whole square in the denominator. We get this. Now simplify this. This is, again we know that if we operate 1 upon f of d on sine ax, then we know that we substitute first d square by minus a square if denominator is non-zero. Here a is 2. Therefore, we substitute d square by minus 4 in both the terms in the denominator. We obtain this step x 1 upon in the bracket minus 4 plus 5d as it is plus 4 as it is. Operate on sine 2x is equal to, sorry, minus numerator is 2d plus 5 divided by minus 4 plus 5d plus 4 whole square. Operate on sine 2x. We simplify this. This is x 1 upon 5d. Operate on sine 2x is equal to 2d plus 5 upon 25 d square. Operate on sine 2x. Now this x upon 5, 1 upon d means integration of sine 2x dx minus 2d plus 5 upon 25d, and we operate 1 upon d on sine 2x means it is again integration of sine 2x dx, and we know that x upon 5 as it is, and the integration of sine 2x is minus cos 2x upon 2. Now again integration of this sine 2x is minus cos 2x upon 2, and this minus sign becomes minus minus plus this term as it is. Again we want to operate 1 upon d on this. The first term is minus x cos 2x upon 10 plus 2d plus 5 upon 50 and integration of cos 2x dx. Now you are let this integral 2d plus 5. Integration of cos 2x is sin 2x upon 2, and this 50 becomes 100. Now this is equal to minus x cos 2x upon 10. Take 1 upon 100 constant outside. 2 into derivative of sine 2x. We know that the derivative of sine 2x is 2 cos 2x, and this 2 it becomes 4 cos 2x plus 5 sine 2x. We simplify only this bracket, we get this. This is our yp, particular integral, or you may call particular solution. And then we write the general solution is y is equal to yc plus yp. Therefore, y is equal to c1 e to the power minus x plus c2 e to the power minus 4x plus minus x cos 2x upon 10 plus 1 upon 25 cos 2x plus sine 2x upon 20. This is the general solution of given non-homogeneous differential equation in which q of x is of the type x into v. We see another example. Solve the equation d square minus 1 of y is equal to x square cos x. As usual, we consider the auxiliary equation m square minus 1 is equal to 0. Therefore, factors are m minus 1, m plus 1. Therefore, m is equal to 1 minus 1. Roots of the auxiliary equations are real and distinct. Therefore, yc is equal to c1 e to the power x plus c2 e to the power minus x. Or you may write this as to be yc is equal to c1 e to the power minus x plus c2 e to the power x. Now we want to find the particular integral yp. Yp is equal to 1 upon f of d. Operate on q of x. Here f of d is d square minus 1, and q of x is x square cos x. Therefore, we obtain yp is equal to 1 upon d square minus 1. Operate on x square cos x. This is equal to 1 upon d square minus 1. We rearrange this term as to be x into x cos x. Therefore, this becomes the term of the type x into v, where v is x cos x and this is f of d. Therefore, again we use this formula and substitute in this formula v has to be x cos x. Then we obtain this yp is equal to x 1 upon d square minus 1 x cos x minus derivative of this f of d is 2d upon, if we take the square of this, we get d to the power 4 minus 2d square plus 1 operate on x cos x. Now we first operate 1 upon d square minus 1 on x cos x. This we take as it is, this term as it is, we take the derivative of this. This is minus 2, derivative of this is x as it is, derivative of cos x is minus sin x, plus cos x as it is, derivative of x is 1. And we want to operate this 1 upon d square minus 2d square plus 1 on this minus x sin x plus cos x. Now separate this term x 1 upon d square minus 1 x cos x plus 2 1 upon d square minus 2d square plus 1 operate on this x sin x, this minus minus becomes plus, again this minus 2 1 upon d to the power 4 minus 2d square plus 1 operate on cos x. Again we use the formula for these two, and for this third term we substitute d square by minus a square if denominator is non-zero. We separate one by one. We operate 1 upon d square minus 1 on x cos x. Again use this formula. Using this formula, here v is cos x. We get this x 1 upon d square minus 1 cos x minus derivative of this is 2d upon d square minus 1 bracket square operate on cos x. This is equal to x substitute d square by minus a square. Here a is 1 cos ax. We get this minus 1 upon, again we first operate this on cos 2x. This 2d as it is, and 1 upon d square minus 1 whole square on cos x. Substitute d square by minus a square. We get this term. This after simplification we get this minus x cos x. If you simplify this, this becomes here. This is minus x cos x upon 2. This is 1 upon minus 2 square 1 upon 4, and these 2 gets cancelled. This is minus 1 half, and the derivative of cos x is minus sin x, and this becomes minus minus plus. Therefore, we get minus x cos x upon 2 plus sin x upon 2. This is the first term. Now the second term, 2 into 1 upon d to the power 4 minus 2d square plus 1 operate on x sin x. Now v is sin x. 2 as it is x 1 upon f of d to the power 4 minus 2d square plus 1 operate on sin x minus 2, derivative of this is 4d cube minus 4d, and operate 1 upon d to the power 4 minus 2d square plus 1 whole square on sin x. This is equal to 2x, substitute d square by minus a square, means substitute d square by minus 1 square minus 2 into minus 1 plus 1 of sin x minus 2 4d cube minus 4d. Again same, substitute d square by minus a square, a is 1. We get this. Now simplify this. After simplification we get the first term. This minus 1 square becomes plus 1. This is plus 1 plus 2. This is plus 2, means it becomes 4, and this 2 upon 4 is 1 half, and this x sin x means we obtain this first term minus 2 4d cube minus 4d sin x. If we simplify this is minus 1 square is plus 1 plus 2 plus 1. This bracket is 4, its square means 16 sine x. And now we operate this on this. We get, after simplification, this is 2, take 4 outside, this becomes 8. After taking 4 outside, it becomes 8. 8 upon 16 means we have 1 half, and the third derivative of sine x, and then the derivative of sine x, and rearrange the term. After simplification, we get this is to be cos x. This part is an exercise for the student. To do these calculations, we obtained the second term as to be cos x. And now the third term in that equation 1 is to be 1 upon d to the power 4 minus 2d square plus 1, operate on cos x. Again, we substitute cos d square by minus a square, means substitute d square by minus 1. We obtain denominator as to be 4, cos x as it is. We substitute from equation 2, 3, and 4 in equation 1. We have yp is equal to this. After substituting this, means addition of this term plus this term plus this term. We take the addition of this term. Here it is 2 term, here 2 term, and this is 1 term. And we combine the like terms, we get this. Here x sin x upon 2, x sin x upon 2, it becomes 2x sin x upon 2. 2 gets cancelled, we get x sin x. This term as it is. And this cos x minus cos x upon 2 means cos x upon 2. This is yp. And then we write the general solution is y is equal to yc plus yp, and y is equal to c1 e to the power minus x plus c2 e to the power x minus x square cos x upon 2 plus x sin x plus cos x upon 2. Now we see one more example of this type. Solve d square plus 4 of y is equal to x sin x. Again, consider the auxiliary equation. M square plus 4 is equal to 0. The factors are m minus 2i. M plus 2i is equal to 0. Therefore, m is equal to plus 2i minus 2i. Roots are complex, conjugate, and non-repeated. Therefore, yc is equal to c1 cos 2x plus c2 sin 2x. We know that how to write this yc. Now, yp is equal to 1 upon f of t. Operate on p of x means yp is equal to 1 upon d square plus 4. Operate on x sin x. Here again, this is of the type x into v, where v is sin x. Where v is sin x. Therefore, using this result, in this result, we choose v is equal to sin x. Then we obtain yp is equal to x 1 upon d square plus 4, operate on sin x, minus 2d upon d square plus 4 whole square, operate on sin x. Again, we substitute here d square by minus 1. Here a is 1. We obtain this is equal to x 1 upon minus 1 plus 4 into sin x minus 2d upon minus 1 plus 4 whole square sin x. After simplification, we get x sin x upon 3. This is minus 2 upon 3 square, means minus 2 upon 9, and derivative of sin x is cos x. This is yp. And therefore, we write the general solution is y is equal to yc plus yp. Therefore, y is equal to c1 cos 2x plus c2 sin 2x plus x sin x upon 3 minus 2 upon 9 cos x. We have seen the 3 examples on this topic, and I hope this much is to be sufficient to understand if the q of x is of the type x into v. Now take these examples for practice. These are the exercises for you. Solve these examples. Now see here, second example belongs to both the type e to the power ax into b and also x into b. In first case, if you take e to the power ax into b, then b is x. If we take this x into b type, then b is e to the power 2x. Means this example we solved by the two methods. Okay, now stop our today's lecture.